Computer. Morning, everybody. This is the first official cluster API provider nested office hours. This meeting will be recorded and posted to YouTube later, so don't say anything you wouldn't want shared with the whole world. Yeah, to kick this thing off, I don't think we have anybody that's new yet, at least not on this call that I can see. But everybody knows everybody already, right? Cool. Now, would somebody mind actually taking notes in this agenda? You all should have edit access as long as you're part of the SIG cluster lifecycle. I just want to make sure that everything gets documented as well. Please add yourself to the agenda, to the attending list so we can document who's all here. And cool, I'm going to share my screen and start off with the first thing that's on our list, which is kind of just an overview. I wanted to get something out in place that we could talk about architecture. Cool. Can you all see? Can you all see Chrome?
Yep.
Cool. All right, great. So let's see. So we have, the first thing I wanted to talk about was I pushed a proof of concept. This is not to get merged. This is more just to talk about the architecture. So I wanted to throw this out there for everybody to look at it. The idea here is it kind of follows around what, Faye, you and I have been talking about this for a little bit, and Chow have been talking about this for a little bit, and we've talked about this internally. But the idea of using multiple CRDs to actually push this thing through. So we have, so in essence, we'll be creating a, let me go and find this control plane. And that's a nested control plane. But in essence, we have like a nested control plane type, which implements the same functions as the virtual cluster CR. So things like cluster domain, a template ref, the PKI expiration, pretty much everything that you already implemented, just pulling that over into a control plane type. And the idea here is the control plane types allows us to have a reference from, as a control plane reference from the nested cluster resource that we'll actually be implementing. So this is the implementer of the nested cluster. And the how it's all actually done from a controller perspective is using multiple controllers. And this is where I'm interested to hear everybody's thoughts. But the idea is it goes and creates, I'm going to actually find the nested control plane. So the nested control plane reconciler, in essence, what it's doing is it goes through, checks to see that there's a template ref already added to it, fails if it doesn't, just added a bunch of random stuff in here. But then it goes through and it will create resources as it needs to. And instead of doing everything implemented in a single controller, we actually have multiple resources that implement different separate functions. So I kind of broke it down into the nested PKI, which I have a note in here that we can bike shed about the naming. I don't like that it's called nested PKI, but the idea is it goes and manages all the certificate management, similar to how KubeADM does all of the certificate management and how VC does it, but not in a single controller. And the idea there is you can hot swap that controller if you don't want to be using the default implementation. And say, for instance, you have your own routes that you need to be generating all your certificates based on. Then so on and so forth, it would go and create another resource, which would be the nested etcd. And again, we can bike shed about all the actual naming of this, but the idea is the nested etcd could be just a shadow resource. So it goes and implements pretty much nothing in the spec. If I can actually get up to the types.go file for this. Come on. Cool. One more. There we go. So it pretty much doesn't implement anything in the spec, but all it has is status fields. And the spec, we can implement things as we find parameters that we want to submit in as optional things to change. But the status actually manages how to get the addresses, for example. And so now we can have independent implementations. And say, for instance, somebody wanted to go and use what is it? There's a new etcd operator that you could go and implement. You could implement this control or this CR going and reaching out and creating whatever that etcd cluster is. And then it just has to add in the IP address or the host and the ports so that the next downstream object can go and use those things in the, say, for instance, the API server flags. This is kind of the architecture that we were talking about before. I wanted to throw this out there, kind of just open up the conversation about this, and then yeah, that's about it.
Yeah, I have a few comments. So
Please.
first come to the nested control plane.
Yep.
Yeah, by the way, I don't have a chance to look at this change.
No worries. I pushed it about 5 minutes ago, so I totally understand. And so I want to just open the conversation up to any thoughts and feelings and about it, and then yeah, move forward from there.
So Chris, can you give you a little bit overview why you do this? Is any advantage compared to current architecture?
Yeah, so there's a couple things in here. So by implementing each piece as a separate component, we're able to replace any of them that we need to. So for example, if you didn't want to use the current inbuilt stateful set for etcd, you could go and implement a controller that goes and creates an etcd full cluster that it could go and actually run against. And that cluster can have its own lifecycle built around it. So things like we could implement backup and recovery into that controller, for example. Same with the API server and controller manager. Right now, the implementation, everything has to get updated all at once. And as we all know, etcd, the way that it's implemented currently, is completely ephemeral. So the second we start updating this, you lose your entire cluster state. And so the idea is if we can separate all those components out, you'd be able to independently update the API server and then roll out a new version of the controller manager, and etcd doesn't even have to be touched. Same with as we go through and get into the long-term management of these clusters, the PKI is going to eventually have to expire, and we're going to have to update those. And so providing individual phases that we can update those will make it a little bit easier in the long run.
Okay.
Yeah, so, okay. So and you go back to the nested control plane. So just that CRD, actually.
Yeah.
I think this is, let me think about it. So the workflow wise should be, this is the entry point, is this? Or
yep. It'll be 2 CRs. That's the one thing where, well, it'll technically be 3 CRs including the template, but it'll be 2 CRs for every cluster. So you'll have a nested cluster and a nested control plane. I just haven't implemented the nested cluster type.
Nested cluster type. What is that actually?
Yeah, so that acts as like the intermediary to tell Cluster API where everything is and how to work with it. And the idea here is you need to have an implementer for a provider that implements whatever your cluster is. And so this is the control plane provider reference in the nested cluster. And that tells Cluster API's functions that we could use things like the cluster resource set, and we could use the health checking that's built into Cluster API and don't have to go implement those ourselves.
So I think that, so this is basically represents the nested control plane. So all the control plane components is represented by this CRD. And the relationship between this CRD and the nested cluster CRD is who calls who? I mean, who created who?
You have to create them both at the same time. And the idea would be Cluster Cuddle can actually do the scaffolding for that. So if you go do like the Docker implementation, or if you do the Docker implementation for Cluster API, like their actual quick start, what it does is you end up running like some, forget the exact command, but it's Cluster Cuddle config create -- provider -- something else, and it will generate all the manifest files, and you can write that to you can write it to a file, and then you can just kubectl apply that, and then everything gets created behind the scenes for you.
Yeah. So I think so I just don't quite. I understand the workflow, but I just don't quite understand why you need to create 2. But I think we were discussing how about just create 1, or
we were, and so that's where it wouldn't fit with the Cluster API model to actually use the other objects like the health checking that's built into Cluster API. So if you have the nested cluster and if you have a nested cluster alone, it's not going to know how to go and connect into the control plane to do things like control plane health or deploy add-on resources like what you wanted to talk about after this, which is like the cluster resource set. And so you have to have the base level, which is the cluster, and then the cluster has a reference to something that goes and implements it.
Okay.
It's
anyway.
the same thing. Like currently, it's every cluster is implemented using, if it's not EKS or AKS, it's implemented using the kubeadm control plane provider. And so we're in essence creating a nested cluster or nested control plane provider.
Yeah, but so to me, I think it's just the loose couple and the tight couple thing. Because if you put a ref in the spec, this is pretty much just loose couple because there's no, the ref can be anything, right? But
Yep.
if you put exactly spec type in the another CRD, is a tight couple because you said this component has to follow this CRD. This is my understanding. Maybe I'm wrong. But are you saying that we have other? So even to the nested cluster, we probably have another type of the control plane design, or this is the only one?
This is the only one, technically, but in Cluster API, they have the control plane reference or the control plane providers, which can be any different control plane provider. And so we're implementing ours, which does a nested implementation of it.
Okay, so I think it's okay. We put this, loose decoupling these two things. So then that's fine. I just have a few comments. For example, I think in this design, you can, I don't think this is, by definition, this nested control plane spec has to mapping exactly with VC object. Because to my understanding, as I said in previous meeting, I want to decouple this. So this only deal with the control plane. So there's no API to tell how to use it, basically. So which means, for example, the transparent meta prefix, opaque pattern prefix, this fusion should be moved out because this is very specific to VC implementation.
Yeah, that's true. That's absolutely true.
Yeah, I think
that's
we have
a very good point.
This
I'm gonna add notes in here.
needs to be removed, and let me see.
FYI, I'm going to go on mute while I type. But yes, absolutely. That's a really good call out because a lot of this is just pulled straight over from VC so that we can re-implement those functions.
Yeah, namespace, a namespace should be fine. Namespace, yeah, okay. So what are the template ref? Is this describe the EDC the class version, the previous class version? Oh, the template ref.
Yeah, so the template ref is an object reference that references a nested template. And a nested template looks like what we were originally talking where we have, there it is, where it basically has components and components have names. And so you name your components, SED, controller manager, and API server, and it will provision those three resources for you. And that's what this in essence is a mirror or re-implementation of the cluster version CR.
Okay, so but the Kubernetes version, so is this a rule for, because for etcd they shouldn't use this Kubernetes version, or so?
The idea here is that it's that's a really good point. The idea here is supposed to be like the golden state for deploying a new Kubernetes cluster. So whatever you're supposed to map to each version of Kubernetes from an etcd perspective, or like the right state for this. And so the idea is it's a template that provisions the entire control plane.
I understand. So that but the implication is that we probably have to do the strict, version range check. So this is
Yeah. So I did a really loose version of that where you basically can't version down. You can only version up, and you can only version patch versions, like we all talked about a couple weeks back before we had an official meeting. So basically, you can update a patch version, which will roll out a new release of it, but you can't change the minor version as it currently stands.
Okay, that's pretty okay.
We'll go back up to the
so the
control plane.
Yeah, PKI expiration day. Even the PKI stuff, if we have a controller, should this be moved out, or what do you think?
So that's Yeah, that's one of the interesting things. I think it could be passed through. And I've been trying to figure out if we want to make it so that we have, I've been struggling a little bit, to be honest, with the CRD explosion here. Because the amounts of CRDs that behind the scenes are actually getting created is a little bit much. Because if you do, if the way that it's implemented currently is it creates a nested PKI, like shadow CRD that just has status. Now, technically this could have the PKI expiration on it, but that means that up front, you need to create that CR from, you as a human need to create that CR versus this orchestrating, creating that CR for you, if that makes sense. Because it's kind of like a chicken and egg there, where technically this should end up being implemented on that CR in the spec field, since it's a parameter that you can change. So. Right.
Let me think about it. I think it's more like, how do we want to manage roles CR? For instance, if people want to change it, what are the right way to change?
Right.
We ask them to change this top level spec, or change individuals controller independently. I think this is all about. I think this is a broader question, actually. If you remember, we talked about how to upgrade roles components, right?
Yep.
We can just let individual operator operate the version by their own. We don't care about the version. We only collect them. We only have an entry point to find all of them, and we don't have an entry point to do the upgrade. Basically, we don't implement. This is one option, right? Another option is we take full control. Every upgrade need to go through the one single entry point. Then our new controller, to do all the upgrade for you. Or,
right.
Yeah, even if we don't do the upgrade, we can call out the other operator to do the upgrade. But the question is, where is the entry point to do this? I think this problem can be combined. For instance, but I think we discussed before, right? That if we want to, for example, for template ref, if you want to change your new version, we just hard code to give another, to make each template is immutable. If we want to change the template, we just change the template ref to a new template.
Right. Yeah, and then it rolls out behind the scenes as well. Yeah.
Yeah, in that regard, maybe it's good to put a PK here, because every time you want to upgrade something, you have to go here to do all the upgrade.
Yeah, keeping it all in a single thing makes it so that we can at least make the initial implementation much simpler, so we don't have to create as many CRs out of the box. Because if we do it so that PKI is managed through the nested PKI, again, don't agree with the name, but just use that for right now. But if we do that, where we implement the parameters for PKI on there, unless we had, I guess we could just have same defaults, but to do that, what you do is when you went and called cluster cuddle config, you would go and generate each one of these CRs with the value, with like the defaults, which is totally possible. At the end of the day, we're just scaffolding those CRs up front, versus letting this controller go and orchestrate creating everything for you.
Interesting. Let me think. So another thought is, do we put certain manager in the template, or so? You understand what I'm talking about? Currently, our template is only for the control, the mask component, like add CD, CCM, and the API server. Should we put manager as part of it?
Manager as part of
it. Cert manager, certification.
Oh, yeah, it's an interesting idea. Yeah, it's an interesting idea. I know I've talked with James Munnelly, who used to work on, well, still works on Cert Manager, about that. It would be interesting to see if we could use that to do all the generation from the supercluster. Basically, run it outside of the nested control plane, and use that to do CSRs against, to create for these clusters.
Yeah. So let me think about.
I don't know if we added it in here, it would be implemented for every single control plane separately.
But will that be maybe it's too much, or? I don't know if this is a reasonable request or not, or because if
It's interesting. Go ahead.
Yeah, because currently what we say is, okay, different TM can have different expiration date. This is only
Mm-hmm.
they come from the same sort of manager to do. They share the same root CR. Root CR, right? They come. So we are assuming we're using whatever sort of manager in Supermaster.
Mm-hmm.
Do the PKI creation kind of thing. I don't know. Is it reasonable to consider to put individual certification manager for each TM, or that work? I think it still works.
I wonder what would happen. I mean, you'd end up deploying multiple cert managers into your supercluster at that point, because it wouldn't be running in the individual the tenant control planes.
Yeah.
So I don't know if it would. I think it might be that you'd have to run it as like a supercluster resource.
It is, but I think maybe it is not it is not necessary for our use case, at least for now, because
sure,
our use cases we can just use the same the Supermaster.
But is it safe to disclose all the Nest cluster certification in a central place?
it is. It currently is. Well, it's
but
currently implemented that way. Yeah.
So everyone can find this someone's certification, or do we have the security measure to make sure that only the tenant can have its own certification, but not everyone else?
If it's deployed in the supercluster, then we wouldn't have to worry about it, because they'd be hidden from being able to access it.
Okay.
But if it was deployed in the singular into tenant control planes, I think they're going to be doing that anyways to be able to deploy things like operators.
I think the only requirements is tenants need to spread the certifications for their users. This is the only thing I can think of. But I don't think there's no such use case for now. But for design perspective, maybe we can think about will that be useful or meaningful. At least for now, in a very early stage, I don't think people will do that way. But who knows? If they want to generate certification for their users, what should they do? They can implement their own, or we can follow up. We use class API to do these formal things, to do all the configuration for the cert manager if they want.
I think that is a good call. I just added a note on there. We can bring in James as well for this. There's definitely some stuff in here that we could do from what Chao originally had implemented. There's a couple things in here that we definitely can't implement that way. If I drop down in here, things like generating the kube configs and things like that for the controller manager and the API server, we'd have to implement those separately. But I think we could probably at least generate the root CAs and the API servers and etcd certificates and keys.
Yeah, so I think this may be a broader question for Intel class API. So do they do the things like what I said? Maybe it is reasonable for them because they are actually use class API to deploy kind of supermaster kind of thing. So if you think about that way, it is good to include a certain manager. But for us, maybe it's too much, maybe waste too much resources, but maybe we can leave the flexibility if we want to do that later.
So Cluster API, the way that it implements it, it actually does kubeadm to do all the cert generation. So it doesn't use certificate or cert manager to do any of those. That being said, the management cluster that provisions these technically uses, out of the box, uses cert manager to do things like set up the webhook TLS, but I don't believe it uses it for any of the actual downstream cluster creation.
Okay, I understand. But it makes sense. If for other, AWS, they do have their own Intel certification system to spread the certificates. So maybe they don't put the manager. But anyway, for us, we probably the only thing we leverage upstream is cert manager, or we do this everything by hand, like exactly what it show in the screen.
Yeah.
Okay. So yeah. Other than that, so for etcd part, can we check? So for etcd part, you said there is nothing in the spec. So we don't need to specify the version, or what do you think?
I think we definitely can. I left it blank for right now so that we can add to it as we go. I'm just trying to create like the simplest implementation first. Pulling over what we implemented with stateful sets as the first implementation, and then changing from there is the idea.
Okay, so let me sort of make it clear. So the etcd part for now, you said, you know, we better make it flexible in the sense that if people want to hook to their own etcd operator, they just build a glue code by themselves and plug into the stack.
Yep.
So for us, do we, because we are now, we are currently using, you know, put every storage in the memory is ephemeral storage. Should we keep it that way, or we need to have some implementation that use actual storage?
I think we should keep it that way. So my theory, and anybody else, please add your thoughts in here. My theory is that we should do the first implementation similar to the way that we have it structured with VC, because it does work and it proves out the model. Now the underlying controller that implements it, the idea there for passing between each one of these. So say for instance, nested PKI down to the nested SIG to the nested API server to the nested controller manager. The idea is to move from one phase to another in the actual provisioning lifecycle, implement each one having a ready function, and the ready function is what tells it. And so the controller actually, what's actually implementing it isn't quite as important out of the box, because the idea there would be if you created an etcd operator that was full functional, because we shouldn't be implementing that. That's something that other folks have already done, and we should just leverage open source tools at that point. So what we would have is you could create a new nested etcd controller that goes and creates the CR to go create whatever operators behind the scenes. And then your nested etcd controller, all it has to do is update the status fields and set it to ready and set the host names and ports so that the next phase can move on. So I'm thinking that like lightest weight, don't even worry about making sure that there's persistent storage in here, keeping it the same way that it's implemented with in memory.
Okay, so I understand that's reasonable. So for now, we just by default you will get ephemeral storage. So this is by default kind of thing. We can either implement by default very simple controller for etcd is ephemeral storage etcd. So we can do that, and give exactly the way that you said. So we probably, which means we have a default etcd controller somehow.
Yep. Yeah, there is one that's started in here, but it has nothing implemented yet. But the idea was that it's going to grab the template attributes from the nested template and be able to create whatever it needs. So in that implementation, it's a stateful set. It's going to look for a stateful set, and then it's going to mutate its status.
Mm-hmm. Okay.
Chao, what do you think as well? You're on here. You implemented a lot of the first one, so I want to make sure you got your thoughts in here as well.
I think it looks good. I'm thinking about we're going to use the Kubernetes builder to implement all these three controller, right? The etcd controller, API server controller, and the controller manager controller, right?
Mm-hmm.
That's the plan. Okay.
Yeah. So all the components will follow the way that you said, right? So they update the status for the. So do they update a single place or a separate space actually?
They each have their own CR. That's something that I've been thinking about as well, whether we want to just update the status on a single CR being like the nested control plane, or have an individual CR for each of the components and manage the status across those CRs. Because that's totally feasible as well, where we could have, so if the nested control plane so if the nested control plane under status, besides just having cluster namespace and its own ready field, if it had, say for instance, etcd hosts, and it managed the etcd host there, and then we had something like etcd ready as an attribute, we could technically do this using a single CR and have multiple controllers reconciling the same nested control plane CR. It's kind of a...
So by the way, let me think about it. So question is, how does the nested control plane knows what are the full list of the subcomponents that need to be ready? So how do they know the list of the components? Do they put it in the spec? I don't see it.
They don't. So the idea was that it was going to create out of the box. It was going to create from the template. Always create etcd, controller manager, and API server. Just every one of those. So in the template, the component config, or sorry, the component add-ons has a name attribute. Always name them etcd, controller manager, and API server, and then we can just loop through those, grab the right one, and then apply that to the cluster. So it doesn't have a list of all the resources because it's not doing more resources than those currently.
I see. So they probably have to, so you're saying that they have to check individual template spec to see everything that is in the template spec. That is, by, if we want to extend it, we just extend that template spec with the right format saying that we add another add-on controller. We check that. Okay.
Exactly. And then we can do something where we're like, as we build out those things and realize, oh, we need to make sure that we support this attribute as well. Say, for instance, we implement some crazy scheduler on top of it that, I don't know, does something weird. You could have it do an injectable to check to see if it's defined. And if it's defined, it goes and deploys it. But if it's not, it doesn't deploy it, kind of thing.
Yeah, but I see etcd definitely we should go that way because the actual implementation is very user specific. But for the controller manager and API server, do we need to do that? Because that we probably have to introduce another CR. So we probably have too many CRs. One CR to represent another CR to represent that one who actually create API server.
Right. So that's the one thing that I'd been still noodling about whether we wanted it to be that way or not. I think I see some benefits of doing it that way, where if it needs to get updated, it's pretty easy to touch it and say, make sure that you're using, say for instance, when we do an update, it's easy to say, is this CR in the right state? Because we have it at the API server and we're not going to update the API server and the controller manager at the same time. For example, we could do a rolling update of this API server CR gets touched, and that triggers a reconciliation of just the API server resource. And we can technically do that with a single resource, a single overarching control plane CR too.
That I understand, but my question is, should we need to, let me try to put it this way. Should we provide the exactly solution to upgrade the API server? As I said, so basically you have a template. So etcd, we actually, we put it in, we do it in the way that unless the default, you can do the upgrade. Otherwise you let somebody, whatever you use, do the upgrade, right?
Yep.
API server, maybe another, the one thing that you can do, we just have one CR which say API server CR, but we implement the actual controller. The controller is responsible to changing the version, the CR version.
Yeah, so we update I got what you're saying. Yeah, we update the lifecycle, or we manage the lifecycle of API server and controller manager inside of CapN.
Okay.
And yeah, I think that's the right way of doing it. It's exchangeable at that point still. So like, as long as it still supports the ready attribute, somebody could turn off. The idea is basically make it so it's pluggable. If somebody goes and implements a different way of managing control planes, say for instance, because there's lots of folks out there, as we've seen from the multi-tenancy working group, like the Loft folks or the kiosk folks, they're all implementing different ways of doing, even Arctos, different ways of doing these virtual clusters, and they're using things like K3S to provision it. Now, technically, if we do this right, we could support those implementations being wrapped into CapN, as long as we make it so that if you turn off the API server and controller manager and etcd controllers, and you write your own that goes and provisions whatever you have, at the end of the day, it's just a spec.
I think that's okay. I think.
But yeah, having same defaults in there would be is definitely useful for us moving forward.
Yeah, having a default, and we still need to provide a capability to upgrade the default. So that's what we do. And for the design perspective, I think it's straightforward. You can just whatever, because it's a template wrap. So what we need is you need to tell me what is a ready flag, where to check the ready flag, and the centralized controller just keep polling that ready flag. If every component is ready, we mark ourselves is ready and tell the upper controller to do the rest of the thing.
So it sounds like if we have some other providers, say if Apple have a pool of API server or control plane that is ready, then we can use this API, but behind this API, we are actually calling the Apple maybe API or Open API or something, and then provisioning an Apple's internal controller plane, and that one will be used by this tenant master, right? If we do
Yeah.
the API server design correctly. Okay.
Yeah, exactly. Yeah. At that point, it could be, and it would be the same thing for what you all are currently doing, where you're calling out to the Oliyun control plane to go create your control planes. It would be, you could re-implement the those controllers specifically to talk to whatever public API or internal APIs. Yeah.
Yeah, but our side may be slightly different because what we got is a bundle. It's everything. It's not individual. So that's okay. Yeah.
Yeah, you could still implement a single controller that was like, when one of these resources comes through, the single controller is listening for all three of the etcd controller manager and API server, and it just goes and does everything for you, or it doesn't even have to listen for those things if you don't want to at that point.
That's the control plane is already working as a bundle. So right, if it is ready, it's a bundle ready. It's not an individual component ready. So
yeah.
Okay. I think it's fine. I don't have further comments about this high level thing, but yeah, I do like to see how you do this. That's a nested cluster stack, because it's not here. I know you haven't done that, but I think this part is kind of clear to me, at least to me. I don't know if you other guys have other comments, but I'd like to see the nested cluster stack.
Okay.
We still need to be very, or we better document the way that how the exact workflow. If I am an administrator, what is the exact workflow to do the provision? You said we need to create a 2CR. Then we have an order problem, or what do we expect? So for example, for control plane, I'm clear. So if I create a control plane CR, I can just, as a client, I can just keep polling the ready state. If it is ready, then it is ready. How about the nested cluster CR? What are as a client, what should we need to watch about that?
Gotcha. Yeah, the implementation, I believe, is pretty simple. So it basically implements the control plane reference, which points to this control plane CR. And then the status fields, it has the conditions, and then it has a ready status. And the ready status is what tells Cluster API, oh, I can move on to do whatever I want. So if I wanted to go and deploy the cluster resource set into this new created control plane, it has an endpoint so it has ready, conditions, and a control plane endpoint. And it can now hit the control plane endpoint and go and create whatever other like add-ons need to be deployed into the cluster.
I see. So basically, it is the nested cluster controller keep polling the control plane, nested control plane CR to see if it's
You
ready.
got it.
It is ready. Mark myself ready, and then tell my client to do the rest of the thing. Okay. Still,
you got it.
That is the end. Okay.
So the idea there is yeah, go ahead, Chao.
Yeah, I have a question. So what about if we wanted to install some extra add-on like core DNS or something like that? That will be happen in a cluster CR or in a cluster control plane CR.
So it will be a resource. Apparently, I wrote it as SETI. Let me go and actually cluster. So the idea here is that by implementing all of this, we have access to use this cluster resource set. And the cluster resource set, it does a reference to config maps. And those config maps can be any type of resource that you want to deploy into the cluster. So say, for instance, you wanted to deploy core DNS, maybe you want to deploy OPA or Gatekeeper or any of those things. You add those into the supercluster as a config map. And then when you do the initial bootstrapping for the cluster, so say, for instance, when you create the virtual cluster CR and the virtual control plane CR, you can create a cluster resource set CR that points to all of those add-ons that you want to deploy into your cluster. And now when the virtual cluster CR comes to a ready state and you have a control plane endpoint, it will loop through the resources in here and deploy them into your cluster for you.
Okay. Yeah. That sounds good.
Okay.
So many components in here. It's wild.
It looks a little bit strange, but I can somehow understand. So this is kind of a common part you can extract out of different provider. Basically, regardless the provider stuff, this is a common part. So they extract, and they didn't put it in the individual, provider spec.
Yep. It makes it easy, because then if say for instance you wanted to have like an all-in provider that goes and creates all-in control planes, or if you have a provider that goes to AWS or Azure or anything like that, all of those add-ons can get deployed to every single one of your clusters from your individual management cluster. So
let me think about it. So let me think about it. So this only define the resources, but the actually code implementation is done by ourselves, by the controller actually.
For the resource set, no, that actually gets implemented because it knows when the nested cluster is in a ready state and has a control plane endpoint, it can deploy those into that nested control plane, because it also knows where the kube configs are.
Yeah, I understand that, but my question is, who do you actually provision? Because this tell you what you provision, right? But who does
Gotcha. Yeah, an admin. So whoever's creating the cluster.
No. I think I thought this should be provisioned by the controller. No, because
sorry, we jumped a little bit forward. So when you deploy all these things, you have to deploy the cluster API controllers as well, which is what operates those things. So the cluster API controllers are deployed into your management cluster, and then you have a provider which implements our implementation. And so there's a whole set of controllers that will manage the life cycle of these resources, any of the top level resources that aren't in our individual provider. And so it's a completely separate controller that we don't even have to build or think about. It just goes as long as we set the proper attributes on our CRs.
Let me think about it. So, okay, if I understand correctly, the way that it does is we got a control plane ref, and we put that ref into some of the CR of that controller, saying that controller means install all the resources defined in this class resource spec in that control plane.
Yep.
How it works?
It will be as long as you select the cluster based on this.
Oh, interesting. Okay. I see.
Now, that being said, there's also, because of the way that we've built this, we can technically do this a little bit more funky. If we don't like this implementation, I would say that we should go down this path, because I think it's going to be the most supportive of everything else that Cappy's doing. But if we don't like this, technically we do have a weird patch around ours because of the nested template. Because the template has, where is it? There we go. Because of this components list, technically you could implement something that goes and add like core DNS into your cluster if you wanted to. If you need like a golden state for every single control plane, there's always that. Out of the box, I'd love to support everything that Cappy implements, just so we don't have to do it. Because they're going to have health checks against those add-ons and things like that, and make sure that if an add-on that you told it in the cluster resource set isn't working properly, it'll go and reapply it to the cluster and make sure that it tries to bring it back to the right state, which I think is a really nice benefit that we don't have to implement.
I see. I think this has a value, has a point as an upstream solution. I think it is formalized the way that how to do the provision as on. You just give me a control plane ref, then the controller will do the rest of the thing. The only thing is that spec maybe looks a little bit simple. You only give a list. We probably can talk with upstream guys if we want to enhance that resource. I mean, enhance that controller. Like this brings out my very initial proposal or topic to you guys to say, because our internally have requirements, even we have a resource, I want to have an order of how that, the order of provisioning of those resources. Maybe the right way is actually point to the resource spec, the cluster resource spec, this CRD, right? Maybe this one can enhance to support the order kind of thing. And let controller handle the rest of the thing.
That's interesting. Yeah, that's a really interesting use case. Is that so that you could have things like you always deploy cert manager, that you then, after you have cert manager up, you can deploy webhooks, and then once you're able to deploy webhooks, you can deploy things like OPA into your cluster, and then, oh wait, you needed to have Core DNS first because nothing's going to work without Core DNS. Is that kind of the idea?
Yeah, exactly. So, but I believe for internally, because we have some legacy issues, we have a bunch, I think our cluster has about more than 30 controllers. They have dependencies, so
sure.
Issues. So either we change the order or they change the order, because if we don't change the order, every containers need to change the logic to wait something else to do. So it depends. It all depends on the implementation, right? So if you have some legacy controllers, they require the dependency of the others. Our infra can support ordering. That's just a bonus. It's not a strong. If we don't do that, they have to change that code if they have strong dependency.
Interesting.
Yeah.
I wonder if you, so I believe, and this is, don't quote me on this, but I believe one of the main things where this original object came from for CAPI was, if you're familiar with the cluster add-ons group, at least, the cluster add-ons group has been building operators that manage the lifecycle for resources within your cluster. So you can deploy a Core DNS operator, which goes and deploys Core DNS into your cluster, which is a little bit weird because now you're operating, now you have an operator that's creating another deployment in your cluster. Same thing for like OPA or Gatekeeper or whatever, all the other components that you could deploy into your cluster. I wonder if that would be the implementation, because I think what we could have here, what in your implementation, you could have a CR that goes and creates that ordered set. So instead of having to manage the order in like a physical list, you could have, when this deploys, the operator goes and checks to see if everything else is there and doesn't deploy until it's in its proper state. Kind of basically telling it the desired state and then letting Kubernetes reconcile it.
But the question is how many CR we need to write, because it seems to me.
True. Yes.
You can list everything, right? The other way, you just make it the array be a single element, and you create a bunch of CR. You ask another operator. That's definitely doable, but I mean, from the user perspective, I feel it's more reasonable. We can just have a central place to kind of register everything in the central place, and somehow you tell them the order. So if they specify order, so the controller will honor the order. So I don't know, maybe, I don't know if
it's an interesting idea.
Yeah, I don't know if it's a common requirement or not. So, but anyway, I think I found the right place to point our guys to take a look at it. We should look at this one.
There is a whole design doc on cluster resource set, if I recall correctly in here. Experimental. Yeah, so if you're not familiar, CAPI has its own form of KEPs, but they're, yeah. So this was the KEP for cluster resource sets. So I have not fully read through this, so I might be wrong in the way that it's structured. But the idea there would be, if you're going to deploy Calico, you might need to do this, and you need to deploy it once, for example, into your cluster. But yeah, point your folks at this and see what they say, and see if there's things that we need to change.
Yeah, can you show me the link? Yeah,
absolutely. Let me put this in here.
Somewhere, yes.
I'm just going to put that under that list, or that item.
Useful. I think we should take a look, but I think that's the right place instead of the way that you were saying we add more in the components. That's too much for us, at least.
Yeah, fair.
This components should be somehow limited to the control plane object only.
Right. Yeah, I agree. I think it should be. And then using this to deploy anything else we need to into the cluster.
Good. I think we I'm okay. So we have about 8 minutes. Should we list things to do, or what do you?
Sure. Yeah, let's do. Cool. Yeah, how do you want to handle this?
Testing upgrade. But then I look at the time.
It sounds like I should go and implement or somebody on our side of things should implement what the nested cluster looks like, so we can actually look at that and get definitely finish out the proof of concept so that it can deploy a control plane into a cluster. I think is one.
Yeah.
I think how about you guys? Yeah, I think you guys need the two CRDs, a nested cluster.
But I won't be able to finish.
Let me show
you my screen.
All right, there's a little bit of feedback.
Yesterday, Kavita was asking.
Wei, I think that might be. There we go. Wei, I just muted you. I apologize for that, but there's a little bit of background.
So I think you guys can implement nested controller CRD. Yeah, let's first divide the work. Then we probably need to separate the meeting to exactly talking about the name. We need to give it the right name. I don't want to change the name later, so we need a better thing about the name. At least before next meeting, we need to decide the name. Yeah, that's a good naming. We need to define decide the naming. I wish we can do it this week. Controller-wise, I think we can divide the nested cluster, and nested control plane, these two CRDs. Maybe you guys can handle it, or you guys can handle that, including the CRD and the controller. And I think Charles, since he's all the VC manager, I think he can take care of the currently 3 in the API server, controller manager, and etcd. That 3 CRDs with current default behavior. There's not much behavior-wise is very similar to current class version and VC manager, but just I believe that is mostly like it is code restructure and kind of workflow restructures. Functionality-wise, already I think since Charles was implementing the old version, maybe it's good for him to take over this part of it.
Cool. That makes sense to you, Chao?
Yeah, that makes sense to me if you guys agree.
Yeah.
I think
cool.
These two things are pretty separate as from my perspective. We can do it in parallel. There's no strong dependency right away. As you said, you guys can just we are another provider, just set a flag ready. And you just assume, you just keep holding that ready.
Yep. Cool.
Sounds good.
Yeah.
Okay. Then please, Chris, you just start the issue. Let's talk about the naming in the issue.
Sounds good. I'll start something outside of this meeting and then drop it into the CapN Slack channel.
Okay. Cool.
Cool. I'll make a couple I'll make a couple other issues about this so we can track against actual GitHub issues, and then drop some links into that channel as well.
Great.
Okay.
Cool.
Sounds good.
All righty.
Has any questions or comments? Okay. Then see you next week.
Cool. Thanks, everybody. See you next week at 10 a.m. next Tuesday.
Bye-bye.
Okay. Thank you, everybody.
Yeah.